Hello everyone, I am Nitij, and in today's video we will be exploring anti-patterns in React and how to avoid them. I will walk you through each one, showing you why they are problematic, and then I will also show you the best practices to follow instead of those anti-patterns. This is going to be incredibly useful if you are a new React developer or even an experienced one as well to refine your skills. Okay, so the first anti-pattern that I will talk about is overuse of complex state objects. So in functional components, we can use useState to create state variables, but sometimes we make those state variables too complex. We add a bunch of properties to a single state variable object and even nested properties as well. This makes it harder to update the state variable with deeply nested objects and can even lead to error-prone code. The better approach is to split complex state objects into multiple useState calls. So for instance, over here you can see that the useState hook is being used to create a new state variable. Now there are nested properties for address, street and city, and when we have to update any single property, then first we have to spread out the rest of the properties by calling this single set state function. Now this over here is a very big overhead and can lead to introduction of bugs when not handled or maintained properly. The better approach is to use individual state values for each of the properties. So for name, age and address, we have individual state variables, and when it's time to update any one of them, then we do that without worrying about misconfiguring other state variables. The second anti-pattern is a misuse of useEffect for fetching data. So when a component mounts for the first time, then a common mistake that we sometimes do is to not properly use the useEffect hook for data fetching, because normally when we are fetching data from useEffect, then it is dependent upon one or maybe more values which we provide as the arguments for our API calls. Now what we sometimes do is we miss to add those arguments as dependencies for our useEffect hook. This can lead to unnecessary API calls, or maybe when the arguments update, then new calls are not made, so the component keeps on displaying stale data. So the API parameters which change over time needs to be added as a dependency for our useEffect. For instance, over here, when the component mounts or loads for the first time, then we are fetching the data using user ID, but we are not adding user ID as a dependency to this dependency array. When the user ID prop will update, then the data is not going to be updated based on this new user ID. The better approach is to use the user ID as a dependency in this array. This makes it easier to track the state updates based on the parameter updates which the API calls are using. Next one is ignoring use callback and use memo. So use callback and use memo, they offer minute performance gains, but when our application becomes too large, then all of those gains pile up to provide big chunks of performance improvements. So for those situations when you might be thinking that your large React frontend is becoming slower as you are adding more and more components and features, then not using use callback and use memo effectively can be one of the reasons. So use callback helps to memoize callback functions, and use memo can be used to memoize expensive calculations, but still try not to overuse them because that can also lead to other memory related issues. So for example, the anti-pattern can be like this: when we are not memoizing the output of this expensive calculation, where we are iterating over some items and returning a new item in each iteration by calling a function which is expensive to execute. The better approach is to encapsulate the function within use memo, so that when the same item appears again as an argument, then the cached result is going to be returned instead of the expensive function executing again. Next one is very common, and so many solutions have been built to prevent this exact anti-pattern, which is prop drilling. So prop drilling is a big issue in functional and both class components, where props are passed through several levels of components. This makes it harder to maintain those props and our code becomes more error prone. Now for this exact issue, external third-party packages like Redux or Justland have been created, and the context API was also created for this exact thing. So for the code example, we are passing data from the grant parent component to parent component, and then from the parent component to the child component. The better approach is to simply encapsulate our parent in the context provider and then provide the data as a value, so that both parent and child will be able to access the same data which is being stored by the data context. The last anti-pattern that I will discuss in this video is the improper use of custom hooks. So custom hooks are a very useful but powerful feature in React, and they are used for abstracting away code logic which is meant to be used across multiple components. Now, when we improperly use the custom hooks, then we can easily get issues like memory leakage and making it harder to maintain or debug our custom hooks. So as an example of the anti-pattern, from this custom hooks use effect hook, some async operation is going on and the set state is being called when the promise is returned. Now, why is this problematic? Consider a scenario that the component which is using this hook unmounts, but this async operation is still going on. Now, because it's still going on, the JavaScript is not going to garbage collect this callback function. When the promise will return, then this function is going to get called, which simply means that this set state is also not going to be disposed, and this will lead to the problem of memory leakage and unintended behavior. Now, the better approach is to simply use an isMounted variable. So when isMounted is true, then only call the callback function when the promise returns. When the component unmounts, then we need to provide the cleanup for our effect hook as well within our custom hook. And within the cleanup, we can simply set isMounted to false. This will make sure that if the async operation is still going on, then when the promise will return, then the set state will not be called because the isMounted is false. And that wraps up our session on React anti-patterns and best practices. I hope this has given you a clearer understanding of common mistakes and how to avoid them, making your code more efficient and maintainable. If you found this tutorial helpful, then please consider subscribing to this channel. It really supports me and enables me to bring more content like this to you. Thank you for watching, and remember, happy coding and always keep learning.